Hello friends, welcome to CodeChef. This is Suraj, and in this video let's discuss this problem, I need ammo. So now let's understand the problem statement. So here in this problem there is a game with total n players, and we'll be given a list of total n integers where the ith integer represent the unit of ammo ith player has. And before entering into the game, the team leader wants to make sure that all the members in this game must have equal number of ammos, and in order to do so there is only two operations possible. So now let's understand these two possible operations. So first operation is two teammates can exchange one unit of ammo. So what does it mean? Let's say this is player A and this is player B, and if player A has more ammo than player B, then a player A can give one ammo to player B. So this is the first possibility, and the second one is a team member can loot one unit of ammo from a nearby building. So let's say this some player C, and if the player C has less ammos than the other teammates, so what that player C can do is player C can loot one unit of ammo from the nearby building. So final ammo of this player C will be incremented by 1, and both of this operation will take 1 unit of time to complete. And in this problem we need to minimize the time needed to make sure all the teammates have equal amount of ammo. So now let's understand the input and output structure. So in the input, first we will have T, the total number of test cases. Then for each test case we will have two lines. So this is first test case, this is second, and this is third. And for each test case, first we will have n, the total number of players, and then we will have total n integers on the next line. This represents the total number of the initial ammo the ith player has. Okay, and in the output we need to just print one integer representing the minimum time needed to make the total number of ammos of all the players equal. Now let's understand the test case. So let's consider the first test case here. Here the total number of players is equals to 4, and here is the list of ammos of each player. Initially the first player has 7 ammo, second has 8 ammo, third and fourth have 6 and 4 respectively. So initially let's say t equal to 0, this is the state, and let's say for t equal to 1, what we can do is this 8th here this player can give one ammo to the third player. So the final state will become 7, 7 and 7. So now all these three players have equal number of ammo, and the last player has 4 ammos. Now let's say for t equal to 2, what this fourth player can do is fourth player can loot one ammo from the nearby building. So it will become 7, 7, 7 and 5. And let's say for t equal to 3, again this player can loot one ammo, so it will become 7, 7, 7 and 6. And at t equal to 4, it will become 7, 7, 7, and this player will again loot one ammo, so it will be incremented by 1 and it will become 7. So at the end, at t equal to 4, now all the players has equal number of ammos, so this t equal to 4 is our answer. So you can see here. Now let's understand the approach with the help of second test case. So here the total number of players is equals to 6, which is equals to n, and then we have total n integer representing the total number of ammos of ith player. Okay, and here in this problem, first of all, what we need to do is we need to minimize the time, and in order to minimize the time we need to find optimal final state. And what does it mean, optimal final state? Here it means the final number of ammos of each and every player. At the end everyone will have equal number of ammos. So what exactly that number is? So let's represent it by k. So we need to find the optimal value of that k. Okay, so now let's see this test case. 7, 3, 10, 2, 3, 8. Okay, so we need to make two important observations. First of all, let's see this one, 7 and 3. If 7 will give one ammo to 3, okay, so it will become 6 and it will become 4. And then if 6 will give one ammo to this one, so it will become 5 and it will become 5. So when we are exchanging an ammo, we are actually bringing two of these players close to each other. Okay, so when we are exchanging an ammo, we are actually satisfying two players, okay, at the same time, okay, in a single unit time. And let's see the another thing. Let's say for this player will increase its ammo count by looting. Okay, so it will loot one ammo, it will become 3, and it will loot one ammo, it will become equal to 4. So when we are looting it, we are incrementing our ammo count. Okay, indirectly we are satisfying our count. And when we are looting it, we are only satisfying one player, and when we are exchanging it, we are actually satisfying two players. Okay, so here our preference would be first to perform exchanges and bring all the numbers as close as possible to each other. Okay, and after that we'll perform loot. So this will be our strategy. And the third thing is, what would be the final value what we want to achieve. Okay, so we also need to figure out final value. So let's see this one. So in this test case, initially the total number of ammo is equals to 3, and there are total 6 players. Okay, so if we'll divide this 33 by 6, we'll get an answer equal to 5.5. Okay, so from here, actually, if we are just performing an exchange, so we can say that we can distribute 5 ammos to all the 6 players. And after this distribution, we need to distribute 3 more ammos, which we can distribute to starting 3 players. Okay, so it will become equal to 6. So we have performed the exchange operation. So after this operation, now total is 3, but all these numbers are closest as possible when what we can get here. Okay, and then the second thing is loot. So now the remaining 3 players can loot, and this can loot and increment by 1, this can loot and increment by 1, this can loot and increment by 1. So it will become equal to 6, it will become equal to 6, it will become equal to 6. So from here we can say that if we'll our final value here equal to 6. So if we'll try to achieve the final value equal to 6, we'll get a minimum time. Okay, so this is the conclusion what we can make. Now how we can calculate this final value for using some mathematical operations, because we need to make sure that our players, the count of players will stop at the final value, because here we can loot as much as possible. So we need to make sure this should stop at the final value. So how we can calculate this? So here you can see that after we divide 33 by 6, we'll get 5.5. Okay, and what does it mean? It means that we can distribute 5 ammos to all the 6 players and we're left with something. Okay, and it means that few members will have 1 ammo more than 5. Okay, so if few members have 1 ammo more than 5, then other members will have to loot and will have to get up to that level. So if we'll take a seal operation here, it will give us 6, and here 6 means in the final state what will be the number of ammos at each player. Okay, so we can conclude that final value here is equals to total divided by n seal. And now the last task is to calculate the minimum time. What will be the minimum time? So the minimum time is equals to the total number of operations we are performing. Okay, so now let's see it. So first, let's say this player can give 1 ammo to 3, so it will become equal to 6 and it will become 4. So this is the first operation. And this 10 here, it can give 2 ammos to this here, so it will become equal to 8 and this will become 6. So till now we have performed 3 operations, and then this can give 2 ammos to this side, so it will become equal to 4, and this will become 6. Okay, and here this 8, this can give 2 ammos to this, it can give 2 ammos to this, so it will become equal to 6 and it will also become equal to 6. So till now we have performed how many operations? 7 operations. Okay, so t is equals to 7, and this one here, this player can loot 3 ammos, it will take time equal to 3. So total time here will be equal to 7 plus 3, which is equals to 10. Okay. So from here we can make one conclusion, that actually the total number of operation we can count just by observing the players which have ammos less than the final value. How? Because here this player has more ammos, okay, and it will give 1 ammo to 3, okay. So we can just measure how far this player is from the final state. So initially it was 3, and this player wants to reach to 6. Okay, so this player is initially at 3 and it wants to reach to 6. So in order to reach 6, it has two options. Rather, this player can take ammo from any other players, or rather this player can loot. Okay, and if this player is taking an ammo from another player, that will also take 1 unit of time, and it will balance this player as well as the another player. And if the player will loot, it will again take 1 unit of time, and in this situation this player will balance himself. Okay, so from here we can make one conclusion, that we just need to observe the players which have a number of ammos less than this final value. Okay, so the player which has the total number of ammos more than or equal to final value doesn't actually contribute. I mean, we can ignore them, and we can just focus on these numbers. So now let's try to see how exactly it works. So let's say we have 3 here, then 2 3. Okay, so this wants to go to 6, this wants to go to 6, and this also wants to go to 6. Here the difference will be plus 3, and here it's plus 4 and it's plus 3. We actually don't care now from where these numbers are coming. It can come from another player, okay, or it may come from loot. If it is coming from another player, then well and good, both of them will be satisfied. And if it is coming from loot, then well and good, this current player will be satisfied. Okay, and why we are doing this? Because actually the player which has the more number of ammos is actually giving his ammos to the player which has lesser number of ammos. Okay, so here always the ammo will come rather from loot or from the player which has more number of ammos. Okay, so if we just calculate the difference between the final state and the initial state of the ammos, will get the result. So let's see here. The difference here is equals to 3, and difference here is equals to 4, and here equal to 3. So here sum is equals to 7. Sorry, 7 plus 3. 3 plus 4 is 7, plus 3 is equals to 10. Let's see now in this example here. Here our final state was equals to 7, and there are 4 players. So let's see, 7, 8, 6, 4. Let's ignore the player which has greater than or equal to final state. So we'll only care for now these 2 players. So this player need 1 ammo, and this player here need 3 ammo, and we can add this up and we'll get a result equal to 4. 3 plus 1 equal to 4. So I hope you understood the logic. Now let's see the implementation in C++. So here I have already implemented the basic template in main. First I'm accepting T, the total number of test cases, then I'm calling solution function for each and every test case, and for each test case we have first n, the total number of players. So let's input it, and then we need to input the initial ammo count for each player. So let's create a vector size n, and then we'll input this entire list. Okay, and now we need to calculate what will be the final value. So in order to do this, first we need to get the sum of the numbers. So we can do it in this way. Let's use long sum is equals to accumulate a dot begin comma a dot end 0 ll. This is a long type. Okay, and let's first see if we are getting some correctly or not. So let's do this and let's run this program. So in the first test case we are getting total sum equal to 25, and then in the second test case we are getting total sum equal to 33, and in the last one we are getting 10. So it is giving correct result until now, and now we need to calculate what will be the final state. So here final units is equals to sum divided by n. Okay, and we need to make sure first convert this into double, and then we need to take a seal of it, upper bound I mean. And now let's see if we are getting correct final units or not. Okay, so for this test case here we are getting 7, and for the second test case we are getting 6. So we are getting the correct final states. And now we just need to check if the unit of ith player is less than final units, then we'll add the difference in our answer. So let's initialize our answer variable. Let's use long answer equal to 0, and then here for int unit of a, we'll check if unit is less than final units, then we'll add answer final units minus, we'll add the difference. Okay, and at the end we'll print answer. So let's see if we are getting the correct results. Okay, I guess we have one more C out here, so let's remove it, and now let's test. Okay, so we are getting correct results here. So now let's try to submit this program and see if the all test cases are passing or not. So our solution is accepted in C++. Now let's see the Python implementation for the same. So here in Python, first I'm accepting t, the total number of test cases, then I'm calling solution function t times, and in the solution function first I'm accepting n, the total number of players, then I'm accepting a list of n numbers, and then here I'm calculating the total here, and then the final units, which is equals to total divided by n, and finally I'm taking the seal of it. Then here I'm initializing answer to 0 first, and then I'm iterating through all the numbers in the list, and I'm checking if the number is less than the final units, then we'll store the difference, we'll add the difference in our answer, and finally we'll print our answer. So now let's submit this Python code and see if all the test cases are passing or not. Okay, so our solution is accepted in Python 2. Now let's discuss the possible error. So here if you will write int instead of long, and here also if you'll use int instead of long, you will get an error. Why? Because this n may go up to 10 to power 5, and the value of this ai will go up to 10 to power 9. Okay, so if let's say if we are adding everything, then this sum may go up to 10 to power 5 multiplied by 10 to power 9, which is 10 to power 14, and definitely that is beyond the maximum value of int. So here you must use long in order to prevent this error. And another possibility here is if you are using the same function accumulate, and if you want initialize this by 0 ll, instead if you will initialize this by 0, then you will get an error. Why? Because this 0 is just an integer type, you must use long here also. So here we are initializing this initial value is equals to 0 of long type. So you just need to make sure these two things in order to avoid the error in C++. So I hope you understood the logic and implementation in both C++ and Python. In case you have any doubt, feel free to write in the comments. So let's meet in another video. Thank you so much.